Hello, it's me, Mary Glenda Romero, and welcome to my video tutorial. In this video, I will share Polya's 4 steps in problem solving and problem solving strategies. Math is an integral part of providing practical solutions to many industrial problems. That is why at early stage, math students are taught to solve different problems so that they will be able to see that they can apply their mathematical abilities to find the solution to a problem. Unfortunately, some students hate math because of their difficulties in the subject. A man once said, "Do not worry too much about your difficulties in mathematics. And I can assure you that mine are still greater." And this is Albert Einstein. This only proves that even the greatest or brightest minds encounter difficulties in math. But what is important is overcoming these difficulties. According to George Polya, mathematical problem solving is finding a way around a difficulty, around an obstacle, and finding a solution to a problem that is unknown. George Polya is a Hungarian mathematician and considered the father of problem solving in mathematics education because of his many contributions in the subject. One of these is the 4-step process for problem solving, and it includes read and understanding the problem, choose a strategy, solve the problem, and check the solution. To understand the problem, you need to look for the information given. You can ask, what is the unknown? What are the data? What are the conditions? Are the conditions sufficient to determine the unknown? Is it insufficient, redundant, or contradictory? You can also draw a figure to visualize the information. And to organize and connect this information, you can think of a suitable notation for the given. After understanding the problem, we need to choose a strategy. We can do it by making representation. You can simply draw a picture, a diagram, or a model just to understand the problem. Making a calculated guess by starting with the desired end result and figuring out and how to get there by checking the patterns of data in order to solve the problem. Making a list or a table is a way to organize data presented in a problem by remove possible answers until the correct answers remain. This part is very important, that's why I'm going to discuss some of the strategies that we could use later in the video. Now, if you have a solid strategy or plan for the solution, we can solve the problem. By using our mathematical knowledge, skills, and logical thinking, this is the solution part in the problem solving process. After finding a correct solution or answer for the problem, we need to check the solution for us to improve and seek alternative solutions if necessary. For example, if Glay has 15 vehicles in her garage, the total number of wheels are 42, and how many motorcycles and cars does she have? As I've mentioned 7 strategies earlier, I'm going to apply 3 different strategies for this problem. First strategy, I'm going to use working backwards. By applying the Polya's 4 steps in problem solving, let's start with the first step. Read the problem carefully several times until you understand the problem. By looking at the given problem, Glay has 15 vehicles with 42 wheels. And what we know that motorcycles have 2 wheels and cars have 4 wheels. What we need to find out is the number of cars and the number of motorbikes Glay have. Second step, choose a strategy. Since we already identified the given, now let's translate them into variables. Let x equal to the number of 4 wheels and 15 minus x equals to the number of 2 wheels. Now let's establish an equation to solve the problem. If you're going to represent this mathematically, we write the equation as 4x plus 2, open and close parenthesis, 15 minus x equals 42. Now let's solve the problem by distributing and arranging the equation. Start solving with the parenthesis. 2 times 15 is equals to 30, and 2 times x is 2x. Now we have 4x plus 30 minus 2x equals 42. Next is to group the variables and the numerical coefficient. Transpose 30 to the other side of equation, it will become negative 30. Let the numbers with variables remain on the left side. We can subtract now. 4x minus 2x equals 2x, and 42 minus 30 is equals to 12. In order to get the x, just divide 2 on both sides. Now to divide it by 2, or just cancel both 2 to get x. Next, 12 divided by 2 is 6, so you get the answer 6. And that is the number of the cars. Next equation, how to get the number of motorbikes. Just subtract the total number of cars to 6, and you'll get 9. That will be your answer for 2 wheels or for motorbikes. To check, multiply the number of cars, which 6 times 4 equals 24 wheels, and 9 times 2 equals 18 wheels. Let's add our answers. 24 plus 18 is 42 wheels. Next strategy will be guessed and checked. Using the same problem, let's organize the given information. We know that there are 15 vehicles and 42 wheels. What we need to find out is how many car and motorbikes are there. Let's organize our solution into table. Please see the table in the video. Starting with 9 cars and 6 motorbikes, the total vehicle is 15. Then, by multiplying 9 to 4 wheels, we get 36, and 6 motorbikes times 2 equals 12. By adding 26 and 12, we get 46. Now that the answer from the guess numbers is a bit higher but close enough to the target answer, let's continue guessing until we arrived at the correct solution. Our next guess is 8 and 7 is equals to 46. This is not yet the target answer. Now let's try it one more time. This time let's use 6 and 9. 6 times 4 is equals to 24 wheels, and 9 times 2 is equals to 18 wheels. Adding up, 24 plus 18 is equals to 42. This is correct. Therefore, there are 6 cars and 9 motorbikes. Our third strategy would be the most common problem-solving strategy is draw a picture. We can draw a picture to solve a problem. A picture can help us to see what's happening. Now I'm going to use circles to represent the number of vehicles. There are a total of 15 vehicles given in the problem. I will draw 2 wheels on each side of a vehicle. 30 wheels are already distributed and there are still 12 wheels left. Now let's distribute again the remaining 12 wheels. Let's add another 2 wheels to each vehicle. This will show you the vehicle that has 4 wheels and 2 wheels. Now let's count the vehicle with 4 wheels. We have 6, and for 4 wheels we have 9. Therefore, there are 6 cars and 9 motorbikes, a total of 15 vehicles. Let's check. 6 cars times 4 equals 24 wheels, and 9 motorbikes times 2 equals 18 wheels. 24 plus 18 is equals to 42. Now I want to introduce a new type of math puzzle to you. This is known as Can-Can puzzle. It is a really simple and easy puzzle to play, as I will demonstrate through the course of this presentation. So without further ado, let's look at what a Can-Can puzzle looks like. This is what a Can-Can puzzle looks like. It is a square with even smaller squares inside of it. A Can-Can puzzle will always be a square. It will never be a rectangle or a circle. So the objective behind the Can-Can puzzle is very simple: to fill each and every small boxes with numbers, as you can see here. But how do we do this? That is the biggest question. So let's look at how to play a Can-Can puzzle. The first thing you need to do when you see a Can-Can puzzle is to try and figure out what kind of Can-Can puzzle it is. This one here is a 3x3 puzzle. The reason being it has 3 boxes on the top and 3 boxes on the side. If there were 4 boxes on the top and 4 boxes on the side, we would have called it 4x4 Can-Can puzzle. Okay, this brings us to the first rule of Can-Can puzzle. The first rule stipulates that if it's a 3x3 Can-Can puzzle, the only numbers we can use to fill out the boxes are 1, 2, and 3. Similarly, if it's a 4x4 Can-Can, we can use the numbers 1, 2, 3, and 4. 5x5, we can use the numbers 1, 2, 3, 4, and 5. So on and so forth. Now in a Can-Can puzzle, you cannot use a 0. There is no place for a 0. You can't use negative numbers. You can't use fractions or decimal. You can only use whole numbers. Okay, now the second rule of Can-Can puzzle is also very simple. If you have ever played Sudoku before, this rule should be familiar to you. So it states that if you put a number down in any one of the boxes, you cannot repeat the same number in the same row or in the same column, which is denoted here by the red arrows. So in this example, we have used 2 in the top left box. Now we cannot repeat 2 again in the same arrow in the same column anywhere else. In the puzzle, you can write diagonally, you can write 2 so. These are 2 very simple rules of Can-Can. So now if you put these 2 rules together, what you come up with is that in a 3x3 Can-Can puzzle, each row and each column will have at least a 1, 2, and a 3. The order doesn't matter, it should at least have a 1, 2, and a 3. So in a 4x4, it would have 1, 2, and a 4. Okay, so let's look at the functional rule of Can-Can puzzle. Now the first thing you see when you see a Can-Can puzzle are these rectangular outlined boxes. These are what we call cages. Cages are used to trap numbers, and it will be our guiding post in solving the puzzle. Now each cage is further subdivided into boxes, and this is how we know how many numbers to put inside the boxes. Each box corresponds to one number, so if a cage has two boxes, that would mean that the cage would contain two numbers. Okay, let's look at the special cage. This one here is called freebie. The reason this is called a freebie is because this cage only has one box and just one number in all. In all the other cases, you will see that there is at least two boxes. There is a number and then there is a mathematical operation. This box has only one box and just a number. So what do you do when you see a freebie is you just write the number down. That is why it is called a freebie. It's a free cage. So the first thing you do when you see a can puzzle is to try to figure out what kind of can puzzle it is. That is going to tell you what numbers you can use to fill out the puzzle. And the second thing you do is to fill out the freebies. Okay, now let's look at the functional rules of can. This cage here has two boxes and it says 5 plus. What does this mean? Where simply what it means is number plus number should be equal to 5. So in this cage, we have to use two numbers, add them up, and the answer has to be 5. So our options are very simple. The first one is 2 plus 3, of course. As I said, order doesn't matter. So it can be 3 plus 2 as well. Now, some of you must be wondering that 1 plus 4 is also 5, but this option won't be correct for the particular puzzle because if you remember the first rule, this is a 3 by 3 puzzle and we can only use the number 1, 2, and 3. If this were to be a 4 by 4 puzzle, we could have used 1 plus 4. Okay, so that's it. That's all you need to know to start solving your can puzzle. Now let's look at all the different operators that you can use in can puzzle. We already saw 5 plus. This one here has 1 subtraction or 1 minus. What does this mean? It means you have to subtract two numbers and the answer has to be 1. So 2 plus 1 is our answer. So 2 minus 2 gives you 1. Similarly, in this one, it is a 3 division. It would mean that we have to divide two numbers to get 3. So the only option we have is 3 divided by 1. This is an interesting one. This cage has 3 boxes, so we would need 3 numbers. It says 9 times. So we would need to multiply 3 numbers to get 9. Hence, 3, 1, and 3. 3 times 1 is 3. Again, 3 times 3 is 9. Okay, so these are all the rules that you need to know to solve your own can puzzle. So remember that if you have put a number down in any box, you cannot repeat the same number in the same row or in the same column. That is how we solve can puzzle. This ends my video tutorial for problem solving and reasoning. Thank you for watching.